Hi everyone, I'm Weizhou from Interactive Media Lab Dresden. I'm going to talk about our work, Where Should We Put It? Layout and Placement Strategy of Documents using Augmented Reality for Collaborative Sensemaking. This is joint work together with my co-authors, Anke Lehmann, Hjalmar Widengren, and Raimund Dachselt. Sensemaking and brainstorming are fundamental tasks in many domains. At present, people mainly rely on the paper, such as sticky notes or traditional desktop, for brainstorming and sensemaking. We believe such tasks will benefit from mixed reality. However, how should we place and arrange virtual documents in mixed reality? Also, how should mixed reality application be designed for this scenario? Lastly, how should a future mixed reality enabled office be designed? Existing work has considered individual usage in virtual environments and also collaboration in this regard. Some people also consider physical environment, but mainly focus on the individual scenarios. We fill this gap by studying the collaboration in a physical and augmented environment. Thus, we designed two configurations of the room. A fully furnished room has around 15 meters square and has been equipped with several pieces of the furniture in order to simulate a typical workshop office. A side furnished room was the same room, but only with a few pieces of the furniture on the side, which allow for flexible space. Besides, we designed two scenarios of the work styles. In a collaborative work style, two users work closely together. In the individual work style, a single user works freely on their own. We design a typical sense-making task for document classification. Participants need to organize and group 50 information cards, either about animal or plants, in a way that makes sense to them and no specific criteria are given. This animation illustrates such a process. Each task lasts for 25 minutes. Participants were instructed to think aloud when working alone, while teams were encouraged to communicate and required to both agree with the final outcome. Based on our research question, we designed a 2x2 mixed design study. The physical surrounding as the between subject design and the work style as the within subject design. We invite 28 participants in our university, and we used Microsoft 2 and the Spatial I/O application to perform the study tasks. We gather and analyze the data from different sources, including observation notes, content placement records, video data, and audio data. On the right, here's an example of the snapshots from the study record in different data sources. In general, we are interested in document placement and layout, affordance, collaboration, and general workflows. We now first report the observed general layout as a spatial layout. Then we zoom in on several ways of the organizing as a spatial arrangement. Lastly, we detail some placement strategies. Firstly, we identify 8 spatial layouts, which are general layouts created for card classification in space. Here we'll highlight some of them. First, cylindrical layout. This layout has little connection with the physical environment and furniture. Cards will group as a panorama strip or semi-cylinders. Here, several examples are given at the bottom. Second, vertical surface furniture-based layout. This layout uses mainly an available vertical surface, especially whiteboards and walls. Below are again different examples. Lastly, omni furniture-based layout, which combine both vertical and horizontal surface of the furniture. Besides, often the room itself, like walls, were used. To further investigate, we count the frequency of all the spatial layouts, as you can see from the diagram on the top. We found that vertical surface furniture-based layout was the most often used, followed by the cylindric and omni furniture-based layout. And in general, diverse spatial layouts were used in our study, from purely geometry-based to reality-based layout. Moreover, those observed layout can be categorized. The layout on the right side of the diagram can be classified as high dependence on the physical environment. Likewise, those layouts on the left can be grouped as a medium and low dependence. Thus, it leads to the second finding of the physical environment that are generally used for placement. On top of that, we compare how different physical environment settings could affect the layout decisions. The results show that the relatively extensive usage of the surroundings can be observed in a fully furnished room, which means the more furniture, the more dependence. Regarding the work style, we found that teams tend to use a physical environment for collaboration. For example, this team was moving the office chair to the center of the room in order to create the visual landmarks based on different components of the chairs. The lower row also shows other teams rearrange the furniture to create a shared space for placement. Participants' comments also prove our findings. For instance, P17 mentioned that he needs chair for adding the sense-making process. One found that furniture can mitigate the limited field of view of the HoloLens, and another pointed out that furniture can facilitate collaborative communication. Next, we zoom in on spatial arrangements, which are strategies for grouping the cluster as categories via separation or as a subcategory via aggregation. We highlight some of them. First, furniture-related separation. This arrangement uses furniture as a natural separators, and it is often combined with other arrangement strategies, like a column or grid separation. Column-based aggregation is a common aggregation strategy in our study. In this case, participants encoded the vertical space as columns to embody the grouping results, as you can see in those images. In addition, poker stack is one of the stack-based aggregation which are often used to represent a high cohesion of the groups. In this case, the cards were placed behind one another, but with a slight overlapping to enable visibility. Regarding the spatial arrangement, participants generally used furniture in diverse ways and to different extents. In particular, tables and whiteboards were used, plus generally free space like canvas. Other examples are shown in the slides. Interestingly, we also found that participants link the real-world experience when working with the virtual content. For example, on the top left, one participant naturally bent his back under the virtual object. Such a link also leads to a semantic mapping placement. For instance, on the top right, the mole was placed on the ground. Also, plants and animals were arranged according to the growing or living altitude of the reality. All in all, we summarize 5 findings of our research. We investigate how people arrange virtual documents in mixed reality. We report the affordance of the physical surroundings. We clarify the characteristic of collaboration. We finally propose following design implementation. For the mixed reality office, we suggest that they should be large rooms and equipped with furniture and plenty of empty surface instead of purely empty space. For the corresponding application, we suggest the functions for automatized layout and placement, and also consider physical environment as design opportunities. With our work, we wish to motivate future research regarding intuitive and collaborative mixed reality system. Thank you for your listening. For more detail, please refer to our paper and our project website.